All right, this is section 3-3, proving lines are parallel. So again, we're going to start with some vocabulary review. All right, so let's write the converse of each statement. So statement that's given to us. If you are cold, then you wear a sweater. So the converse is just the opposite here, or just the reverse, excuse me. So we would say, if you wear a sweater, then you are cold. All right, so here's this statement. If an angle is a right angle, then it measures 90 degrees. So the converse is, if an angle measures 90 degrees, then it is a right angle. So the converse of a statement is always, sometimes, or never true. But let's take a look at the first one. If I'm cold, I need to wear a sweater. That's probably true. If I wear a sweater, am I necessarily cold? I don't know. How about this? If an angle is a right angle, then it has to measure 90 degrees. If an angle measures 90 degrees, then it is a right angle. That's always true. So the converse is sometimes true, okay? Not always true. All right, so in this section, we're going to learn or add another word. It's called the exterior, okay? So exterior means on the outside or in the outer region. So two lines crossed by transversal form 4 exterior angles. So let's use our vocabulary here, okay? So here again, two parallel lines cut by transversal, and it creates 8 angles. So to paint the outside of your house, you buy what type of paint? We would buy exterior paint. To protect the protective cover prevents the blank of a book from being damaged, the exterior, the outside. So in a diagram to the right, 1 and 7 are called alternate exterior angles. In a diagram at the right, angles 4 and 5 are same side interior angles. All right, underline the hypotenuse and circle the conclusion of the following statements. If the lines do not intersect, they are parallel lines. So the hypothesis is the lines do not intersect, then my conclusion is they must be parallel lines. If the angle measures 180 degrees, then it is straight angle. Hypothesis, if an angle measures 180 degrees, the conclusion, it is a straight angle. Okay. So we're going to add 2 theorems to our notes here. So this is the corresponding angles theorem and its converse. So theorem 3-2, which we saw in the previous section. If a transversal intersects 2 parallel lines, then the corresponding angles are congruent. So complete the statement for theorem 3-2. If 2 lines on a transversal form corresponding angles that are congruent, then the lines must be parallel. So this is the converse. Go in opposite direction. So the theorem says, the original theorem says, if I know 2 lines are parallel, then I know the corresponding angles are congruent. The converse says, okay, if I have corresponding angles are congruent, then I must know that the lines had to be parallel to begin with. So here's number 11. Use the diagram below and place appropriate markings to show 1 and 2 are congruent. Well, to show they're congruent, I would mark them like this. Okay. So number 12, circle the diagram that models 3-4. So which one are corresponding angles? Well, these are alternate exterior. These are corresponding. All right, 3-5, 3-6, and 3-7 are basically all the same. All right, if I know 2 lines are cut by transversal and they have alternate interior angles that are congruent, then the lines must be parallel. So if I know the alternate interior angles are congruent, then I know I have parallel lines. If I also know the same side interior angles are supplementary, then I know we have parallel lines. If I also know the alternate exterior angles are congruent, then I know I have parallel lines. Okay, so use the diagram on the right. If I know 4 and 8 are congruent, the lines must be parallel. If 3 and 8 are supplementary, they must be parallel. And if 1 and 7 are congruent. They must be parallel, using the appropriate theorems there. Okay. So underline the correct word to complete each statement. So which lines are parallel if I know 6 and 7 are congruent? So I know 6 and I know 7 are congruent. Okay, so angle 6 is congruent to angle 7 is given. 6 and 7 are same side angles. They're on the same side of the transversal. So they are corresponding angles. I can use theorem 3-4 to prove the lines are parallel. So using 6 and 7, then I know which lines? Well, the transversal is B, so the parallel lines I'm talking about are L and M. Are parallel, and the transversal is B. All right, now we're going to practice writing something called a flow proof. So this is kind of something a little bit different. Okay, so the very first thing I'm given, angle 1 is congruent to angle 7. I'm going to fill in this box. Angle 1 is congruent to angle 7. Well, what else do I know from this diagram? Don't I know 1 and 3 are congruent by vertical angles? Okay, so notice how 1s are in both of these boxes. So that must mean by the transitive property, 3 must be congruent to 7. All right, so what does 7 also have to equal? Well, by vertical angles, it must equal 5 or be congruent to 5. So again, look at this. 3 congruent to 7, 7 congruent to 5. So 3 must be congruent to 5 by the transitive property. Okay, let's try another proof. Determine whether lines are parallel. So if I'm given angles 1 and 2 are congruent, so let's mark them, 1 and 2 are congruent. Use the converse of the alternate exterior angles to prove that lines R and S are parallel. All right, so we were given angles 1 and 2 are congruent, given. Well, what about 2 and 3? 2 and 3 are vertical angles. So I've now proven this is congruent. Oh, look at this. 1 and 3 are now congruent, and those are corresponding angles. So 1 and 3 by transitive let me change the symbol here. This should be of congruence. So angles 1 and 3 are corresponding. So which postulate am I going to use or theorem? I'm going to use the converse of the corresponding angles theorem. Okay, now let's see if I can do this using some algebra. All right, so the marked angles are on the same side of the transversal. By the corresponding angles theorem, if I knew C and D were parallel, then the corresponding angles would have to be congruent. Okay, so C and D evidently is parallel, so I can mark it. So therefore, these angles must be congruent. So 3W minus 2 must equal 55. Adding 2 to both sides, 3W equals 57. Dividing by 3, you get W equals 19. Here we go. All right, do we understand what's going on here? Quick check. A classmate says AB is parallel to DC on the diagram to the right. Explain your classmate's error. So let's see what's going on here. Circle the segments that are the sides of angle D and angle C. So the sides are going to be BC, DC, and AD. Okay, so here are the sides. Here are my lines, and here's the transversal. These, in order for the lines to be parallel, in order for AB to be parallel to DC, AB or vice versa, what must happen? Okay, so my classmate identified the wrong pair of parallel sides. Angle ADC and angle BCD are supplementary. And same side interior. So the transversal is DC. So therefore, AD is parallel to BC by the converse of the same side interior angles theorem. Okay, and you should be able to understand these words by the end of this section.